Hello and welcome to my video for security principles and secure programming. The purpose of this video is to explore and expand on the information that was given in Section 2 and 3 of the report. Section 2 focused on common software vulnerabilities today and the solutions that are prevalent for them. Section 3 looked at the state of art in testing and the software that we use in testing. OWASP is short for Open Web Application Security Project. They focus on collaboration to strengthen software security around the world and maintain a list of the 10 most dangerous web application security holes and most effective methods to address them. Convaso states that OWASP is important as they provide knowledge and tools to help in the creation, development, testing, implementation and support of a web application to ensure that security is considered from the start and that the end product is secure. Currently, OWASP's latest top 10 vulnerabilities were released in 2021. They are arranged in order of highest risk first. An important aspect of this diagram is the changes that have occurred since 2017 vulnerabilities. Broken access control moved from its 5th position to 1st with more than 318,000 of common weakness enumerations in this risk, and the 34 CWEs mapped in this risk had more occurrences than any other category. Cryptographic failures was known as sensitive data exposure, but this was considered a broad symptom rather than a root cause, and now focuses on failures related to cryptography. Injection, that was number 1, now moves to 3rd place, and of 94% of applications tested for injection, a max incident rate of 19% and an average incident rate of 3.37% was found. 33 CWEs that were mapped in this risk showed to have the second most occurrences in applications with 274,000 occurrences. It should also be noted that cross-site scripting has become part of this category. Insecure design is a new category in 2021 findings and focuses on flaws in design. OWASP really focuses on this issue being more about practices and methods of software creation. More attention needs to be given to threat modeling using secure design patterns and principles and reference architectures. They also highlighted that insecure design cannot be fixed by a perfect implementation by definition, and that needed security controls were never created to defend against specific attacks. Security misconfiguration moves up from 6th place, and over 208,000 occurrences were mapped to this risk. They highlighted that there are more shifts to highly configurable software, and that it is no surprise to see this risk move up and external entities has now become part of this category. Vulnerable and outdated components were previously called using components with known vulnerabilities and has moved from 9th to 6th place. It is a risk that was hard to assess for OWASP as it is the only category not to have any common vulnerability and exposures mapped to the included CWEs. Common weakness enumerations are community-developed lists of software and hardware weakness types. They serve as a common language, a measuring stick for security tools, and a baseline for weakness identification, mitigation, and prevention efforts. In the report, I compiled a list of CWEs for the top 10 OWASP risks of 2021 to aid with weakness identification in each of the risks and enhance the solutions found. VRCode is an application security company founded in 2006 and based in the USA. Annually, they published a report called State of Software Security. They have published annually since 2010 and are currently on their 12th publication of the report. In this edition, they focused their attention on software security over the last year in comparison against their previous findings and how developers are approaching applications today and how that has changed over the last number of years. In terms of software vulnerabilities, VRCode's State of Software Security report this year showed that in different scans such as static and dynamic, injection, information leakage, cryptographic issues, code quality, server configuration, insecure dependencies, input validation, and encapsulation are some commonly recurring weaknesses. As discussed earlier, common weakness enumerations is a community-developed list of common software and hardware weakness types, and the main focus of the community is to keep the latest weaknesses up to date with what is prevalent today. In the diagram that we see here, we can see that CWEs are arranged by a score ranking. Earlier, we saw CWEs arranged under OWASP's top 10 risks, but here we see CWEs have been arranged by the top CWEs down. It is also important to note the change in rank on the right side to highlight the movement to CWEs from last year, as some of these have moved a significant amount, such as missing authentication for a critical function, by 13 places to number 11. Some of the current top CWEs here relate to cross-site scripting, input validation, command injection, SQL injection, insecure design, cryptographic issues, and authentication failures. However, the top result, out-of-bounds write and out-of-bounds read, relates only to certain languages such as C++. Sanchez et al. Carried out a descriptive study on vulnerabilities and exploitation related to these vulnerabilities because of the number of cases in the last number of years and the increasing social concern. What they found was vulnerabilities with the greatest exploit generally related to causing denial of service attacks or escalating privileges of the attacker today. These attacks can have serious impacts on society and organisations. Denial of services can be used on essential services in areas of government, healthcare and financial, while unauthorised access due to escalated privileges can lead to huge data leaks of sensitive data. VeraCode in State of Software Security version 10 highlighted that the length of time to fix flaws varies between category of flaws. Risks that we have seen so far as high risk by OWASP and common weakness enumerations can take large lengths of time to have a fix rate of 75%. Cryptographic issues take around 180 days for 75% fix rate. SQL injection is around 240 days, cross-site scripting is around 190 days, and information leakage is around 240 days. This on average is to have 75% of applications fixed related to these issues, but there is still 25% that goes on past these days, and most likely have other flaws present in them. Time-wise, we can see there is a golden window of opportunity in each flaw for exploitation from time of flaw identification to fixture. And during this window, any of the above that Sanchez et al. Highlighted or other exploits could happen. In terms of solutions and mitigation to software vulnerabilities discussed, I will focus on this using OWASP's top 10. Broken access control should follow deny by default, implement access control mechanisms, and log access failures and alert admins. In terms of cryptographic failures, data should be classified as being stored, processed, or transmitted, and data that is sensitive should be identified. Do not store sensitive data that is unnecessary, and to encrypt all sensitive data using strong salted hashing functions. Safe APIs that provide parameterization should be used to mitigate against injection. Insecure designs can be avoided by following a secure development lifecycle and with application security professionals to evaluate and design with security and privacy-related controls in mind. They also advise to use secure libraries and design patterns. In terms of security misconfiguration, OWASP suggests having another secure environment that is fast, automated, and easy to deploy ready. These should be configured identically, but with different credentials and all unnecessary features and frameworks removed. Versions of components with vulnerabilities that are present, unsupported or out of date should be removed and replaced with a secure component that is similar. For identification and authentication failures, use multi-factor authentication, implement weak password checkers, and limit failed login attempts. It is recommended to use digital signatures to verify software from source and ensure that libraries and dependencies are from trusted repositories for software and data integrity failures. For security logging and monitoring failures, all logins, access to control and server-side input validation failures should be logged with sufficient user context to identify suspicious activity or accounts, and these logs should be easy to comprehend. Server-side request forgery occurs when a web application is fetching a remote resource without validating the user-supplied URL. On the network, remote resource access functionality should be segmented and denied by default firewall policies or network access control rules to allow essential traffic, internet traffic. On the application layer, all input data from the user should be sanitized and validated to enforce the URL schema, port and destination with a positive allow list. Next, I'm going to discuss and expand on state-of-the-art in testing. Testing methodologies today generally focus on best practice being to carry out testing from the beginning and throughout, and to avoid leaving testing till the end of development. Methods such as testing early and test often, shift-left testing, and continuous testing are popular today because they implement this. It is also important to fix failing tests, collect as much data from failed tests, and create test reports. VeraCode in State of Software Security version 12 shows that a lot of development teams have moved to agile methodologies and automated testing during development. They also explored how developers are approaching applications and how this has changed over the last number of years. They found that security scanning today is increasing and is becoming more part of the software's lifecycle. In the report, it shows that 90% of applications are now scanned more than once a week. Some are being scanned 3 times a week, compared to 2010, which is about 10% being scanned weekly. This is a huge jump in the frequency of scanning. The increase in security scanning is due to different scanning methods being used, such as dynamic, static, and manual scanning on applications. By using different types of scanning for an application, 50% of flaws are being identified and fixed 24 days faster than previous findings. It can also be seen that different types of scanning can show vulnerabilities in different areas, such as insecure dependencies in dynamic scanning, but not in static scanning. This highlights the importance of carrying out different tests on an application to find as many vulnerabilities as possible. This is important as finding a vulnerability early can mean implementing a patch quickly and avoid costly repercussions that could have a huge impact on the company or organization. I moved into looking at static analysis tools being used today. As static analysis tools are becoming more frequently used, Walker ATS states that static analysis tools need improvement in coherency and support from multi-repository applications and using multiple languages, and to support standardization integration mechanisms for third-party frameworks. Furthermore, not all static analysis tools are able to deliver the same results. In Cower and Ayer's study, they found that spot bugs found more bugs than PMD, and some of these bugs relate to some vulnerabilities that were highlighted by OWASP in their top 10 2021 findings. It found these in areas such as use of broken or risky cryptographic algorithms, cross-site scripting, and SQL injection. PMD did not find these bugs. But this does prove that different tools would be better at finding bugs than others, and by extension, some tools would be better at finding certain vulnerabilities than others. They said they would consider building their own tools instead, and Rahman ATL did this by building CryptoGuard. By doing this, they were able to create a tool that did focus on finding cryptographic vulnerabilities compared to other tools such as CrySI, CoverT, and Spotbugs. At the same time, they did have to build this tool to test this vulnerability to a higher standard than what was being currently offered to developers. But the results did show that CryptoGuard was able to find vulnerabilities in the area of cryptography better than other static analysis tools. An example risk in Java is using libraries with known flaws. Viewer code here shows that Java uses the most amount of third-party code and shows that libraries in Javas that are commonly used are increasing over time. They do say that flaws in libraries are decreasing overall across all languages. However, Java remains one of the highest at around 10% of libraries being used having flaws. As Java uses an extensive amount of libraries, this leaves room for a large amount of vulnerabilities that can be exploited. An issue that can occur here if a library or component is being used in a Java application and is not up to date with the latest version, there might be an exploit for it. Finding a vulnerability for a library or component can be easily done using an internet search, but using software such as Metasploit will allow an attacker to search for an exploit for that version that they find in the application and then run it against the application. The Apache version that is found in this NICTO result has a denial of service exploit that can be carried out in the application and will stop people accessing it. Applying this to an essential service application can be a serious issue, and hence security testing is important in this regard. Finally, I would like to briefly discuss some of the findings during testing for vulnerabilities. From manual code review, there were a lot of vulnerabilities found in the application that the report highlights. A lot of these relate to some of the high risks and CWEs highlighted by OWASP in 2021. These vulnerabilities were in areas such as SQL injection, command injection, cryptographic weaknesses, cross-site scripting, identification and authentication failures, exposure to sensitive data due to it being an insecure design, and vulnerable and out-of-date components being used. All the findings were given recommendations and solutions to secure these aspects in the report. During static analysis, spot bugs returned 79 bugs, and each of these areas were explored and given solutions to. From these, vulnerabilities in relation to potential data exposure, potential changes by malicious code, file description leaks, potential performance issues or program crashes, and vulnerability to attacks were found. Conclusively, we can say that vulnerabilities prevalent today were discussed and explored from different sources. Vulnerabilities such as cryptographic failures, injection, and cross-site scripting are causing more issues than others because of their amount of time to fix. OWASP solutions to top 5 vulnerabilities were given and solutions to the top 10 in the video. Testing early and often are considered modern practices in security testing, and security scanning frequently is becoming more custom in the software's lifecycle. Use of different scanning methods is seen to be more effective in finding and fixing more vulnerabilities in an application. Static analysis tools are commonly used but are considered to need improvement to reduce false positives and detect more vulnerabilities. And the application was manually scanned and static analysis with spot bugs was used. Vulnerabilities found were given solutions to and discussed.